Hello students, welcome to my YouTube channel Data Guru Akash. And in this video, we are going to talk about visualization. So in the last session, I guess we had got to know about some of the basic things in pandas and also in NumPy. So that's what our last couple of sessions were. So today we will look into some basic things in and then we will see the the combination of visualization and pandas, that is EDA and pre-processing, exploratory data analysis and pre-processing. Once we complete that, then we'll go into the model building phase. Create a new notebook today. All right, so in this we are using two different modules, Matplotlib and Seaborn. We'll be talking about the Matplotlib, not so much of Seaborn. We will look into the Seaborn in the next lecture, visualization basic with Seaborn. So what I'm gonna do here is pip install. So if you have not installed, so you can run this command, pip install matplotlib and pip install Seaborn. So pip install Seaborn, you can install Seaborn any of these two. Once you have installed them, you can start importing them, right? You can simply import import numpy as np, import matplotlib numpy splt, import and as spd, import Seaborn as sms. So I'm not sure whether we'll be using all of these or we have imported it. Maybe we'll use it or not. We'll see. So basically, we'll look into the basic things in visualization, right? There is a function in NumPy that is np.linspace, right? So if you read np.linspace, and see, this function actually takes the start and stop point, okay? Start, stop, and how many data points I want to start, okay? It will return the values which are equidistant from each other. For example, let's say if I take 0 and 10, and then I give, let's say, 11 values. See what I have got. I have got 1, 2, 3, right? So you see, all the values have equidistance from each other. Like each other no means every consecutive number has the same difference with the other, right? For example, 1 to 2 to 2 to 3, 3 to 4, and so on and so forth. So if you measure them on a scale, you will see equidistance line. So that's what linspace means. Similarly, let's say I want to have 21 values, right? Once again, you see 0 0.5, 0.5 to 1, 1 to 1.5. So any two consecutive number, if you take, the difference will always be the same. That's what it means when I say linearly spaced or equidistance, right? I can even generate 50 values as well in this. See, now no matter how many values you take, any consecutive values, you'll always have the same difference, okay? So now let's say I have this as x is equals to this and x is this, right? So I'm storing this value in x, and remember the sign function. So if I have np.sign, and if I pass this x in here, right? So for every value of x, what am I getting? Am I getting the corresponding sign value, right? So you see, the range is 0 to 10. And in this range, I'm generating total 50 equidistance values. That means on a scale of 0 to 10, you are dividing them into total 50 parts. These are the marking at each positions, right? And for each position, for each value of x, I'm generating the corresponding sign value. And if you see here, in this you pass radian. So the radian value here is in the range of 0 to. So you see, what is the value of 2 pi in radian? 2 multiplied by 3.14. So this is the value in radians. Until 0 to 6.28, it will be one period. So if you want to calculate how many periods will be there, so just 10 divided by 6.28, it will be something around more than 1.5. Okay. You will see when you see the function plotted. So let's say if I want to simply plot it, right? So I have the sign value I have the corresponding X value and the corresponding sign value. Let's store it in Y. Y is equals to this. And then if you simply do plt dot plot, and here you pass X comma Y and see what you have got. Right? So plt.plot is a function that plots the linear data, line plot. So you see, this is a line plot. If you see, this graph is built of line, is made of small lines. You see, if you want to see this, I'll show you. See, instead of 50 value, what if I generate only only 10, right? Or let's say only 11 values if I generate. So what will happen? In this range from 0 to 10, it is generating only 10 values. And for that particular value, it is generating the sign function. Now, if you have more number of data point, the function or the graph looks cleaner, it looks smoother. But if you have less number of data points, since this is a discrete data, it's not a continuous, just drawing point by point only, right? We are not drawing the whole curve because it's not possible to draw the whole curve here in a binary system computer, right? It's not possible. It's only possible in analog systems, not in here. Okay. So here we are drawing simply point by point and then connecting those points by a particular line. See, one point from here, here, and so on and so forth. See, that's why it is built of these small lines. If you increase the number of lines, see what will happen. The curve starts looking smoother and smoother. Now, if you make it 50, you'll not be able to even recognize if there is some, difference. Right here on here, you will be able to see a little bit of, but not everywhere. So this is how you simply plot a line plot, not only with this data, but any kind of a data. And there is something called scatter. The scatter function is something that will just plot the points. It will not connect them together. It will just plot the points. And you see here this Matplotlib connection, that path collection at this is nothing but the position where it is stored. So what we can do, so plt.show, you can simply do plt.show, and you see here it is showing us. This is the plot right now. You see basically in the previous plot, when you plot it by scatter, so they will connect the data points. Otherwise, it will just plot the scatter data points only. Now here, as of now, it is plotting the scatter data point only. That's the two types of plot you see. Now let's see, how can we make customizations in this, right? Let's say you want to make these balls look smaller or larger, or you want to make the plot larger, right? So all the things, how do you do this? So the first thing first, see, in order to control the size, so first you have to create the figure size. So plt.figure, and in this you define the fig size. Fig size equals to, you have to define as a height and width. Let's say if I'm giving 15,9, right? So you see 15 is the length, width, 15 is the width, and this is the height, right? 9 is the height, right? So that's the basic, how you can increase or decrease the size of the chart or size of the figure. And you can also give, so like every plot you see in that graph or in that plot, you can also see the size, the title of the graph, what is on the x-axis, what is on the y-axis, everything you might have seen, right? So similarly in this, to add that, what you can do, plt dot x label. So what is on the x-axis, we can say linear values, and what is on the y-axis, we say plt dot y label, sign values. And similarly, we can add the title as well. So plt dot title, we can add as sign function. Okay. So when I run this, now you see on the x-axis it says linear values, on the y-axis it says sign values. Here the title is also says sign function. If you want, you can also change their size as well, right? Whatever the size of these as well, like you can just pass the font size command into that, right? So let's say if you simply want to increase or decrease, you can simply pass font size. Yeah, font size, let's say is 15 if I have passed. See, the value has been larger. Now, if I pass over here as well on the Y label, it's also larger. And here, let's say 20 if I pass. So you see, these values has been a little bit larger. Before plotting this, you need to understand the basic thing about every plot, right? And every function that you are going to plot or any data that you are going to plot. See, this is the sine function we are plotting. And you know that in a discretized system, in a binary system, this laptop or, the whole technology that is built up on this computation, that is built on the binary system. Binary system is a discretized system. And in this, you cannot plot the analog data, right? To plot the analog data, you need to divide into different data points that can be thought of as a frequency. Now you see in the one period, we are generating 50 values now. Maybe if we can increase to 1100, no, even more as well, but that will still be, just discrete values. It will never be continuous. Even you have a million of data points in there, but it will never be continuous. So this is, that kind of a function, and we are trying to just make as clear as graph as we possible. And sometime in some cases, we don't want them to as well. So that's the basic thing about this graphing thing in Python or any computer system. Now, when you are plotting this, so we are plotting nothing but the x-axis with the y-axis, and we are passing the data as an array, 1D array, and each and every data point has been plotted with a particular dot. With the scatter plot, they will be plotted as a dot. With the the plot method, they will be plotted as a line. So I'll show you. Let's say this is a plot method, right? You can also change their color as well. You can simply pass either C is equals to, let's say I want to make it red. You can make it red. You can also pass, not only C, you can also pass color. Color equals to R, or you can also pass red, the whole name as well. Not only red, you can pass any name. Let's say if you pass Y, so it will be blue. If you pass G, so it will be green, or you can also give the whole name as well. So like this is not, something that I'm passing randomly, and you can pass any color you want. This is well defined. This is predefined. If you want to know what all the colors are there that are predefined, so you can simply go and give it over here. Just go on internet and search for Matplotlib colors, right? So this is the name of the list of the colors here that you can pass. See, by the plot here, directly passing an RGB. You can also pass the name like blue, orange, green, red, purple, brown, pink, gray, something like that as well. And you can also give names like this as well. Not only this, you can also pass the name like color code as well, right? The HTML color code, you might be knowing about that. You can also pass the color code as well. Let's say color code, right? So you can go and check any color, like any color you want to generate, just have a color, and this is the hexadecimal code for that, right? You can just copy this from here. You can just paste it here in this, right? You'll be, okay, wait, I think you need to pass hash before this one. Yeah, so you can just pass with hash, right? So whatever code you select, so this you can find out anywhere, okay? This HTML color mapping, you can find out anywhere, right? You can go find out a color picker at W3, right? So see something like this, right? You can select this and you can copy the particular code here, right? And you can paste that and you'll be able to get that particular color in there. Okay, let's say if I paste this there, right? So I've got that color. Okay. Apart from this, you can make the line thicker. You can also do a lot of things as well, but I'm not going to show a lot of things in here. Let's try to understand. Let's say if you want to have marker into this, right? For example, this is a line plot, but you don't know where are the points, right? So you can also write the marker. Marker is equals to, let's say whatever marker you want me to be. Let's say if you want it to be star, so it will be star, right? So the marker here, marker means each of the data point here, marking of the data point in the plot. So that is now a star. If I make it, let's say O, so it will be O, right? If I want to make it, let's say something, let's say triangle this way, so it is that triangle. This, so it will be this. so on and so forth. Whatever you pass, it will once again it will not take everything, right? Let's say you pass D. D does not mean anything. I mean, D is also there. D means diamond. Okay, so you can also pass diamonds here as well, right? Like you can pass S. S means square, right? C means, I guess, circle. No, C is not there. C is circle, so you don't need to do that. You can pass O. But you cannot pass anything. For example, I cannot pass Q, right? But you cannot pass anything. There are few different things. One again, you want to list off all the markers. You can go again check on the internet. One suggestion for you, for anything that you do not get or you not understand, or like these values, like marker, what are the possible values for marker? You can simply go on internet and check on the official documentation. You can simply search on Google, like the marker for, Matplotlib plot function, right? And that will lead you to official documentation of Matplotlib. Like I have come here. See, this is official documentation of Matplotlib, matplotlib.org, right? So here you will get the different things here. For example, here I am able to see what are the colors that I can pass. So you can also pass the color codes as well. So it's up to you. Okay. So all these things, you can do. And let's see one of the more customizations. Let me make it O only. Okay. One of the more customization that you can do is you can make the marker, large or small as well. Marker size, there is a command marker size. You can also make the line thickness, large and small. So few of the things I will leave to you. You can pass marker size, you can pass line style. Okay, let's show you. Let's say marker size equals to, let's say, 10. So you see marker has been increased, like bigger. Okay, do not compare this font size with marker size. Okay, they are a totally different thing and they have their own scale. If you want to make it big, smaller, then pass it smaller value than this. If you want to make them bigger, then pass a larger value than this. So very simple thing and very understandable, I guess. Okay. All right. Let's say you can also pass the line style. Line style is one of the command, style, that will decide like what line style you want. So as of now, you see it's a solid line, right? But if you want, you can make it, dotted. You can pass, let's say, dotted like this. Now you see the line is dotted, right? It's dotted now. If you want to make it dashed, so you can pass double dash here like this. So you see the line is dashed now. It is not dotted, it is dashed. If you want to make it, let's say, dash and dot, so you can pass dot in here. And now you see there is one dash and one dot. Okay. So these are the pretty basic things you can do. And you can also go and check what are the different line styles available. Okay. Thank you so much for watching this video. If you liked it, do press the like button and subscribe the channel for future updates. Also hype the video so that it can reach more students and they can also get benefited from it. Thank you so much for watching this video. We'll see you again in the next one. Till then, bye-bye and have a great day.